Irrational numbers are quite easy to define. Numbers that never repeat or terminate. Okay, so 3.141579 blah, 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 blah. Pi is an example of an irrational number. It doesn't mean it's useless, it's just the definition. Okay? Real numbers also consist of rational numbers, and rational numbers are defined as any number that can be written as the quotient of two integers. They also must terminate or repeat. Okay, that's in your book. You learned that in 5.1. Now, rational numbers might include, say, 0.625 might be a rational number. 0.83 with a repeater, right? Those are some examples of what might be rational. The square root of 25 might also be irrational. And how about the magic number 6? Those are all examples of numbers that are rational. Okay? Within rational, notice I'm going in now, we have the next level. These are integers. Okay? Integers are rational numbers. Integers are rational numbers, which are also defined as real numbers. Okay? Now, an example of what an integer might look like. Put simply, an integer is a number from 0 on up to infinity, no decimals, and their opposites. Okay? So positive 1, negative 1, positive 2, negative 2, positive 3, negative 3, into infinity. This is an example of an integer. Okay? Just a couple of them listed there for you. And within integers, the final little step is whole numbers. This is any, and I'm going to call it counting number, if you learned that back in 3rd or 4th grade. So 1, 2, 3, 4, 5 on up. It's something you can hold. Okay? I have one pencil. I can't hold 0 in my hand. It's not a sensible thing you can digest, right? But you can hold 1. You can hold 9,000, right? That, my friends, is it in a nutshell. Okay? So as we stepped down, we went from the big definition of real numbers, the separation between rational and irrational. Okay? I took this particular number, this 6, I would call that an integer because 6 is a whole looking number, no decimal. Okay? And within that, we have those whole basic numbers, the normal things you work with. 6 eggs, 12 apples, 47 peanuts. Okay? Let's use this really quick. Rational or irrational, this is the checkpoint below, okay? This is a really simple lesson if you pay attention to all the words. Is 2/3 rational or irrational? To answer the question of rational, can it be a quotient of those two numbers that ends in a termination or a repeat? Haley says it's rational because it's 0.6 with a repeater, right? You guys with me on this? 0.6 with a repeater. How about the square root of 100? Is it rational or irrational, class? Rational. Because 10, normal number. How about the square root of 6? Well, for fun, and your calculator might look like mine. Okay, take a look at that. Doesn't it look like it's a terminating number? Because my calculator ended it there. There's no indicator on a calculator that something terminates. Okay? So, I'm going to tell you that if something is not a perfect square, you can go ahead and call it irrational. Because there is not going to be, more than likely...
Unless it's super binding, but it actually stops.
Yeah, and there's not a lot of those. But you're absolutely right, Philip. That's a little bit tricky. But just keep this in mind, okay? Square root of 6 is 2.44948974. I don't know what else, okay? Just like pi. Okay, and 16 over 25's root, that's 4/5. 4/5 is what, 8.8? Rational. Okay, Lee, are you cool with this so far? How about Hannah? Okay. All right. Graphing irrational numbers. You're going to think this is a little strange. I'm going to go ahead and flip my page here in a second. But the best way to graph a rational number is going to be to come up with a fair estimate. All right? And I'm just going to show this to you real quick. And this isn't in your book. Okay? Square root of 6 is approximately 2.4. I'm just going to chop it off. Okay? 2.4. Okay? Don't look too closely at that triangle business because to me that's more difficult than it needs to be. So if I wanted to graph this, 0, 1, 2, 3, this is about 2.5. So I would define that as the square root of 6. Okay? I would define that as the square root of 6. So if you have to graph something, find its value, plug it in where you best see it. Okay? I'm not going to ding you because this really only looks like 2.25. No. You get the idea. It's somewhere between 2 and 2.5. Okay? Example 2. So now we're going to compare using greater than, less than, or equal to. Okay, square root of 2. Anybody want to plug that in and give me some numbers for that? Give me a to the 10th. 1.4? Yep. And 9/5, let's face it, is 1 and 4/5. Which is 1.8, right? If you can't figure that out, you could plug it in. And 9 divided by 5 gives you that. Okay, but I just knew that it's 1 and 4/5, and 4/5 is 8/10. That's bigger. Okay? That's bigger. If they asked you to graph it, you could graph it. You would say 1.4 is about here. 1.8 is about there. Okay, how's everybody doing so far? Okay, not too shabby, right guys? So example 3, unfortunately, they do force us to graph this stuff. I'm going to show you my methodology on how I do it. Okay, would you agree that 4/3 is 1.3? Okay, 2.8 is still going to be 2.8. Anybody want to give me radical 3 real quick? You guys are all quicker than me because I can't see the buttons.
1.7.
1.7. Okay. What's the square root of 5? 2.2? The opposite of that is negative 2.2. You see that? That makes you say the opposite. Graph all this. In this mess, what's the smallest? And what would you say is the biggest? From there, you should be able to graph it. Not an issue. And again, I don't expect beauty. But I will tell you that if you want me to grade this easily, you're going to give me the original numbers in your graph because that's how the answers are. Okay? So negative 2.8 is the lowest.
Sorry to interrupt. I'm going to go try this again. Okay? Thank you.
Okay, I kind of was a little sketchy here. Let me make that a little bigger. Okay, negative 2.8 has been graphed. How about negative 2.2, which is the opposite of square root of 5? Opposite of the square root of 5. Want to use the numbers in there because it's easier to see. All right. The next item up for bids is 4/3, which is 1.3. Finally, radical 3, which was 1.7. Okay, does everybody see how I took the original list, uncovered its simpler values, and used those simple values to replace that original list onto my graph?
So it just means graph on a line, not an X, not a graph.
XY? Well, there is no XY. Yeah, you're just given one number, but that's a great question.
Oh,
Yeah, when you're graphing a single number, you're using a line. So think about this. A line is one-dimensional, one number. A coordinate plane is two-dimensionals, two numbers, two moves. Great question, Philip. How you guys feeling about this so far? Okay, JJ, how are you doing? You okay? All right, last thing. Everybody gets to the word problems and checks out on me. Please don't do that. Your class is visiting some historical landmarks in Chicago. Outside the Washington block, you break up into two groups. And this totally can happen, by the way. When we go to Kings Island, there's going to be a group that's going to want to ride all the roller coasters. And then there's going to be the group that is too scared to ride all the roller coasters. Okay, forget it. And we're going to make a decision that Mrs. Myers and Mrs. Smith are going to go with the roller coaster riders, and Mr. Jones and Mr. Williams are going to go with the non-roller coaster riders. And at that point, we would separate, right? So we're at Washington Block right now. Look at that picture with me. You break up into two groups. Group A walks 800 meters east. You guys see the movement? They drew a red arrow heading east. Group B walks 600 meters south. Okay? I'm sorry, 800 meters east, 200 meters south. Group B walks 600 south, 200 east. Okay? So basically what they're showing you is two triangles. X marks the spot. X marks the spot. So 800 and 200. By the way, how far is Group A from their original origin? And Group B, this is this group, traveled 600 and 200. Okay, what you might not realize is this is two Pythagorean theorem problems. A squared plus B squared is going to give us C squared. So let's solve A's distance from home plate. Okay, get your calculators out. No. Get your calculators out, folks. 800 squared is, did you guys get 64,000? 200 squared. And then you're going to take the sum of that, which is 68,000, is equal to C squared. What do I do with that 68,000? Find its roots. Oh my gosh, music to my ears. So you find the square root of 68,000. Okay, or I'm sorry, 680,000. Good Lord, Mrs. Myers. Got some zero malfunctions here. Zero. Thank you. Which is 824.6. So we are going to say this distance here is 825 meters from where they originally started. That's Group A's travels. Okay, Group A. Group B was 600 and again 200. Okay, what's 600 squared? 360. 360 and so did y'all come up with C squared equals 400,000? Help me with my arithmetic, I'm not very smart. Square root of 400,000 is 632 point whatever. So we're going to just round that, looks like 632. Are we done answering the question? To the nearest 10, how much further did A travel than group B? A minus B. Most of you have already done all this. Of course, you can see it in the book. 193 further. Okay? 193 further than B. So far, so good? All right, folks. Today, you are doing the entire evens, 12 through 32. Okay? It's only 10 problems, so when you skip one, I'm not impressed. Let's do it.